Welcome to Study Loop.
Hello everyone, today we're doing chapter 17, problem 42. This problem asks us to explain why alpha pyrone reacts with diatomic bromine to yield a substitution product like benzene does, rather than an addition product similar to what we see in the alkene double-double bond addition reactions. So the reason that we get a reactivity similar to benzene is because this compound is actually aromatic. So if you remember, to be aromatic, you need to be fully cyclical. Every single atom in your cyclical structure needs to be sp2 hybridized, and you must follow Huckel's 4n plus 2 pi electron rules. So if you remember, oxygen has two lone pair electrons. One of these lone pair electrons are in the plane of the uh, bonds here in the molecule, so they're not involved in delocalization. But then after that one is filled, we have that pi bond, or sorry, not the pi bond, the p orbital that is perpendicular and facing up and down with all of these other aromatic, or all these other sp2 carbons. And now these electrons can be delocalized around the ring throughout the entire ring here. So because of that, we know that this is actually an aromatic compound. Why? Because even though we only have two pi bonds, we have 6 electrons that can be delocalized here. So it does follow the 4n plus 2 rule as n equals 1. So we actually have 6 pi electrons that can be fully delocalized. And we can actually see that if we draw a resonance of this structure. So if I just were to redraw this structure here, the resonance structure actually helps us visualize that. So if I use one of oxygen's lone pair electrons, I can make a resonance structure that looks something like this. And now what we have is a compound with 6 bonds, 6 pi bonds, showing very clearly that we have 6 pi electrons in the ring, and every single atom here is sp2 hybridized. Therefore, it is aromatic, just like benzene. Therefore, it goes a substitution through a substitution reaction with diatomic bromine, and not an addition reaction, because it is an aromatic compound.